Alright, now let's start with our first feature engineering data preprocessing technique. I'm going to be importing Seaborn. I'm going to be importing pandas. And now we need to load some data. So I'm going to say data is equal to sns.load dataset. And the name of the dataset I want to bring now is called the iris. Let me show you what is iris. This is iris. Iris is a kind of a flower, and there are multiple types of it: versicolor, setosa, and virginica. And here the dataset is giving me the dimensions of its sepal and petal. So if we take a look here and print this data, we will see that it contains setosa species, versicolor species, and virginica. Okay, if you are not seeing all of these right now, if you're not seeing the whole rows, you can simply just add the following, which is set option display max row, and recompile again, and you should see all the rows. Now, we don't have any NaN values here or empty values. All the values are filled. But we have one problem. The species column is actually strings. And as I said, some algorithms have problems when you pass strings to them. They cannot really process it. So let's see what kind of encoding can we apply in order to get rid of these strings. What I want to explain right now is what we call the one-shot encoding. So we have one-shot encoding. Let me give you an example. Let's say here that I have a feature or a label that is called water type. Okay? It's a weird name, but it's okay. Now let's say that we have ocean in my column, I have sea, and I have river. We have learned about encoding when we were talking in previous sections. We said that one type of encoding is to assign a value to every string. So ocean becomes 0, sea becomes 1, and river becomes 2. The issue here is that we are assigning more weight to one label than the other. So maybe the algorithm will say river is more important than sea, or sea is more important than ocean because its numerical value or numerical weight is higher. We don't want that. We don't want to take this risk. What we use is, instead of this regular encoding, we use one-shot encoding. Let me show you how it works. It will decompose this one column into 3 columns. One of them is going to be called water type underscore ocean. Then here we have water type underscore river. And finally we have water type underscore sea. Alright? Now what's gonna happen is water type ocean will be assigned 1 and this will be assigned 0. Since I will be passing all the columns to my algorithm, now it won't consider at all river and sea because they are 0, and it will consider ocean being 1. Now next one is going to be 0, 1, 0. What's going to happen here is, when we pass all the 3, it won't take ocean and sea into consideration, it will take only river to consideration, and its value is also 1. And finally here we have 0, 0, and 1. Let me remove this. Okay. See? Now when we talk about C, we'll see that C is considered as 1 and these two are considered as 0. What we did here is we have assigned equal weight to all of them. So here we have weight of 1, here our weight is 1, and here our weight is 1. See, we don't have any problems when we are talking about a label being better than the other. Because when we say here it's 1, these two will be zeros. When we say this one is 1, these two will be 0. So all of them are equal now. Now let us see how we can implement this. All we need to do is the following. Let's say here data is equal to pd.get underscore dummies, and then you just need to pass the data. Now take a look what's gonna happen. Let me print the data. Here we go. Now we have 3 columns instead of 1. First we had only 1 species, now we have 3 columns. As you can see, setosa is 1 here in all of those because it is setosa. Now versicolor starts here and all of them are 1s. And for the virginica, all of them are 1s here and all the others are 0. So by that we have encoded the dataset and now it's ready to be passed to our machine learning algorithm.